Alright, this is number 8B from the homework. And there's a couple ways you can solve this problem. I'm going to solve it the way they kind of direct you to do it in number 7. So we're kind of solve it that way. And might need to take a couple of videos, but we'll get it done. Anyways, the first thing we're going to do here is we're going to find the vertical distance between these two lines. In other words, from this point here to this point here. We're going to end up making a right triangle at some point. So right away, that point is really easy to find. Okay, I'm just looking at the distance between the intercepts, and that's 15. Okay, from plus 6 down to negative 9, a difference of 15. And then I want to find the horizontal distance between these two lines. In other words, from this point here over to this point there. The problem is I don't know what the x-coordinate is at that point. I do know, however, that the y-coordinate is 6. It's the same as it is right here. This is 0, 6. This is going to be something else 6, something close to 4. So I'm going to plug in 6 into this equation down here and solve for x. So I'm going to go, okay, 6 equals 4x minus 9. Add 9 to both sides, and I get 15. X equals 15 over 4. Work it out if you don't believe me. Okay, so in other words, like 3 3/4. Or sorry, yeah, that's right, 3 3/4. Okay, so x is equal to 15 over 4. Let me just put that here, 15 over 4. So now to get the distance between this distance here, rather, well, because again, I'm starting here at 0, it's nice and easy. This is just 15 over 4. Okay, and the reason why I want that is because what I want to do is I want to find out this distance. I'm going to do in green here for you. This distance here. This is the shortest distance between the two lines. Okay, and if I can figure out this angle here, theta, I'm going to call it. Okay, I already have the hypotenuse of the green triangle. It's 15. If I have theta, then I can find out what this distance here is, the shortest distance. So we're going to use the two sides that we have to find theta. So we're going to do, see, I have the opposite side, and I have, oh, sorry, looking at this, let me get rid of this green stuff. This is confusing for everyone. This is the right triangle I'm looking at here. So I have the opposite side and the adjacent side, so I'm going to go inverse tan of 15 over 4. Well, this is due as a decimal. It's going to make it easier for us. So it's 3 3/4, 3.75 divided by 15. That's going to equal theta. Okay, so I do a little magic on my calculator, and I see that the answer to theta is 14.03 degrees. I'm going to say 14 degrees. I'm going to leave it in my calculator anyways. So I know that. Now then I can look at this smaller triangle there. Okay, and I want to find, I'm going to call it, I'll call it A. Find this length here. This is the shortest distance between the two lines. Okay, so here's my right angle, right here, sorry, there's a right angle. I know the hypotenuse is 15. I'm trying to find the opposite side, so that's going to be sine. So I'm going to do sine of 14 degrees is equal to A over 15, and therefore A equals 3.64. Let's just call it 3.6. Okay, units. And there's your answer. So that's just like how they want you to do for number 7, and 8A and C can work the same way. Hope that helps you.